Hi guys, today we're gonna talk about Leetcode 218, the Skyline problem. So the difficult part about this question is twofold. Number one, the question is actually quite complicated to understand. So that takes a bit of time, but once you understand the question, the algorithm is, I think, not the most complex algorithm to come up with because, you know, it doesn't require a recursion or anything like that. It's sort of a linear kind of algorithm that we're gonna create. Okay, so all this, what we're given effectively is the left, right, and height of buildings. So just give an example. Here is this building. It starts from 2, ends at 9, so it's 2, 9, and then the height is 10, right? So the red building 3, 7, and the height is 15, and so on and so forth. And what we're gonna need to return is the contours of the skyline. So what is the contours of the skyline? So when you just take the outline of these buildings, this point is one contour, and then this is the next point, but then you have this point here, but not this point, and then you have the final point here. So how do we understand this? Okay, let's say if it was a square, or like I don't have a whiteboard right now, but just imagine if it was just like this building here, where you go from 0 to 2 and you have a height of 3, and then from 2 to 5 and a height of 3. So this is just like a rectangle or a square, and the first point is 0, so the leftmost point with a height of 3, right? So if you can imagine it, it's like this point here, but then like imagine if this fills out, then the final point is just this. So the key to understanding it is that the final point always has got to be, which means the point whereby it reconnects with the ground again, because that's what an outline of a building would look like, which is the point whereby it reconnects with the ground again. It's always going to have to be the x coordinate, comma 0, because that's the bottom. And then the preceding one has got to be the previous point that details the shape of the contour, but yeah, and that's basically it. So in a square it would be these 2 points, and then if you have another shape in between, like something like this, then it would be this point, and this point, right? And then if it curves in, then there would be this point here, right? So and effectively what's going to happen is, for every x coordinate you need to find like the highest point, because you may realize that well, actually not really. Okay, anyways, let's stop blabbering on and look at how we can develop the intuition for this problem. Now, as we've seen in the previous video, whereby we did the Sudoku solver, we use this tool to help us get an intuition of how the Skyline algorithm will work, and we'll try to do it again right now.
Varjat Skyline equals function.
Okay,
buildings.
So that was the voice API within the Chrome page, but I think it's not that helpful. So what we'll do is, okay, what we're gonna do is actually we're gonna repeat it 5 times as well. So let CP equals to new set. So these are like the left and right points. So we don't have any duplicate left and right points. So again, another error. So careless error. And what we're going to do is we're going to create a set. So we're going to add the left points, and we're going to add the right points, etc. Then next thing we're going to do is convert the set to an array, and I think we're going to sort the set in ascending order. Yeah. So in certain cases it'll be like these are all the left and right, so like 2, 3, 5, etc, etc. So let n equals to buildings dot length. Now we're not really sure what we're going to do now. Let result equals to -1. So this is I think it's just to set the expectations of like the first coordinate not gonna be within the result that is going to be returned at the end, but it's more like a reference to deduct or to compute what points should be added into results. So let I equals to 0. I, of course, is going to be a pointer for the number of buildings, and because the buildings array is a 2D array. Let height equals to 0. So this one is something that's going to be changing. So while I less than n, which is less than the number of buildings, and buildings, I 0, which is the left coordinate of each building, is less than p, which is the point in the CP1, which is the sorted array of all the unique x coordinates within the array. So if buildings, the right point is greater than p, which is the point here. So if the right side is outside of this point, but the left side is, so if p is within if p is greater than or equals to I and also greater than the right, so it's greater than equal to the left but also greater than the right, so it's outside of the building, then height equals to math.max height. So we're taking the max height for each point, right? So that makes a lot of sense. And then I plus plus okay, then at the end you just, but if the result image is the same height, then you just continue, and then you just result dot push point point and height. So we're taking the max height for every point to be pushed in. So the max height that is linked to the corresponding building. So provided that the corresponding building. So okay, now you can see I'm actually kind of struggling with the solution here. So we'll see if we're able to improve my intuition as we type this along. Right, so let's try again. And this is really going to be sort of like a test of whether this tool is really going to help as a way to build intuition for algorithms, because developing the intuition for an algorithm is something that can take hours, if not days, maybe even weeks. So how do we develop it more quickly? Okay. So it's not height, it's not n. Let P of CP1. What do you need? You need a way to compare. Oh, right. you need a pointer as well to iterate through the buildings. So for every point you're gonna iterate through all the buildings. Okay. And while I is less than n, you're still iterating through the buildings, and the not the point, buildings dot I is greater than dot 0 is less than or equals to the point. So the point is and the point, remember, it's all the left and right points. It's either at or after the left side of the building, and basically you're trying to push all the points into the result, provided there isn't a duplicate corresponding height, or rather the previous height isn't the same, and the previous height will always be the maximum height. Okay, if the building's right coordinate is also greater than P, so the point is either at the left or before the right. If it's at the right, then you'll have to, the height will be 0. So this process doesn't actually happen. So you don't actually reset the height is just 0, and that gets pushed into the array. Oh, I see now. Okay. So the conditions are basically that as you're looping through all the points, you need to loop through all the buildings, find the points that are either on the left side of the building or before the right, and then check the height. Oops, sorry. Or set the height to the buildings, to the current building height, or the max building height that is being found. Okay, and then no matter what happens, just increment the I, because you need to loop through the buildings, right? So if let's see, I plus plus. Okay, sorry. If height sorry. So basically this is what happens if so you don't push anything. Basically, if the current point, the max height of that current point is the same as the max height of the previous point. So for instance, if you have a rectangle 0, 2, and the length is 3, so the max height at 0 is 3, that's what you will find, and the max height at 2 is also 3, so you just skip this and continue, and you don't do anything else. Then once you get to the you don't do anything, because you don't push 2, 3 into this. Although technically speaking, this should never happen, because the max height is not going to be equals to this. It's just going to be correct, 0, 2, and then that will be skipped. But if you have like 0, 2, and 3, and those are the x coordinates, and at 2 is the highest point is still 3, 0 is 3, 3 is also 3, then at 2 it will be skipped, but it will go to 3, and then at 3, but 3 the height won't be the same, because this condition never fulfills, because 3 is equals to P, and the height will just be 0. So this one, whenever this condition is never fulfilled, and then you just result dot push P and height, and that's it really. And okay, so return result dot slice 1. Alright. So now we have the option of maybe trying it out directly in Leetcode, or for me, I feel like I could, and let's just do it. I've actually done this, let's see, how long ago was it? February the 4th, which is about 2 months ago. So let's try to do it now, right? So we're gonna call this CP equals to set, and I'm not sure if the JavaScript set is I believe it's like in caps. Yep. So yeah, and then now what we're gonna do is we're gonna loop through the buildings, and we're just going to use the same syntax that we learned. Add. Okay, now we're just gonna run this periodically to make sure that our code doesn't have bugs. Oops, okay. Hmm. 29375. Okay, that's pretty much correct. So let cp1 equals to cp1.sort wait, hold on. I forgot how to write this. Okay, sort AB A minus B. Two, 3, 5, 7, 9. Okay, it sounds about right. So now next thing we need to do is we just need to loop through for let a point of cp1. Before that, let's create let n equals to buildings dot length, and let I think that's all we need really. So let height equals to 0, let I equals to 0. So I think one of the awesome stuff about linear type algorithms is no matter how complex it is, you can debug it without like those time limit exceeded stuff like recursion, whereby the base case can be a little bit tricky at times. And yeah, height equals 0, let I equals 0, I is less than n, and p is buildings I, and the left side is lesser than or smaller than p if not, height would just be 0. If buildings I1 is greater than p, then height equals to math.max height buildings I2, right? And then I plus plus, right? If height, oh, and I forgot to set this results equals to -1 and 0. If height equals to result.length -1, which is the final previous result, the previous final result, and the height of that. Wow, it looks a bit wrong. Continue. Yeah, this is also for like the starting, so like you know that if it starts at 2, then the height could also be the point, well, it wouldn't actually be 0 unless the point was at 0 and it was a straight line. But anyways, continue. So result.push p height, right? And that's that. Return result.slice 1. Let's take a quick look. Could be wrong though, to be fair, but it is actually correct, which is quite surprising, I must say. Wow, so it works. That's amazing. Okay, so that's how this question is done, and you can see me developing the intuition for it with time. So anyways, I hope you enjoyed that. So thank you so much. Have a good day. See you next time. Bye.